Next presentation will be particular in some ways because this will be a video presentation, but after the video session, the presenters will be here with us to answer the questions and have some interaction. So I would like you to stay, listen carefully to the video, note your questions, put it into the Q&A, because we will have the presenters here, we will have the authors of the video here to actually discuss and answer if you have any question related to the topic. So let's get started.
Hi everyone, welcome to our talk, Microservices, a tale of three heroes. My name's Jovel and I'm a staff engineering manager at GitHub for the apps team. We're in charge of programmatic access to GitHub that allows integrators to customize their GitHub experience. Fun fact about me, my most valued digital properties are my GitHub and Twitter usernames, which are both @Jovel, in case you'd like to reach me outside of this conference.
Hi, my name is Sha, and I'm the VP and Head of Engineering at Catalyst.io. We're a Series B stage startup building an industry-leading customer success platform. Prior to Catalyst, I was VP of Software Engineering at GitHub, responsible for the core platform, community, and ecosystem products. Before that, I was VP of Engineering at SendGrid and was part of the leadership team that took the company public in 2017. Jovel and I have worked together since 2015, both at SendGrid and at GitHub. And now I am 6 months into my new job at Catalyst. It's been such a great experience for us to be part of these three amazing companies during their rapid growth phases, and to see for ourselves the internal changes and external influences that prompted each of their transformation towards microservices. In this talk, we're excited to share some of these learnings and observations with you, and we hope that this will be helpful in your own microservices journey. Companies rarely follow a linear path as they grow. Sometimes it takes a while to get to product market fit. Sometimes the market conditions change, forcing a company to make a hard pivot. Even explosive growth can lead to unintended consequences at scale. GitHub, SendGrid, and Catalyst are all fast-growing SaaS companies, but they're also very different. Different stages and sizes, each with their unique challenges and constraints. We thought it would be fun to follow our three protagonists through their hero's journey as they set out on their adventure, meet some roadblocks along the way, which leads them to problems and perils. Then, our protagonists overcome these challenges as they find their path forward through a process of self-discovery and transformation into superheroes. Before our story begins, we wanted to mention that this talk isn't about the superiority of microservices over monolith. In fact, many successful companies start off as a monolith because of its simplicity. In the early days of a startup, simplicity means agility and speed, both of which are super critical as they focus their attention on experimenting and finding that product market fit. All three of our heroes actually started on this path. As companies continue their rapid growth, products and code bases naturally get more and more complex, and team sizes grow bigger and bigger. This happens until it reaches an inflection point where troubleshooting, planning, and communications become really difficult. And it forces the companies to look for different ways of working. A microservices framework can help companies break down some of these complexities and be more intentional about how to scale their systems and organizations. All right, let's start with our first hero, GitHub. GitHub was founded in 2008. Its call to adventure was to make it easier for developers around the world to host and share their code online. A product that is truly built by developers for developers. GitHub picked the path of Ruby on Rails monolith from the beginning and created a culture of community and collaboration through its extensive ecosystem. The founders of GitHub were open source contributors and influencers in the Ruby community. Because of that, GitHub's architecture is deeply rooted in Ruby on Rails. And over the course of the company's history, GitHub has employed some of the world's best Ruby developers to help it scale and optimize its codebase. This choice allowed GitHub to establish consistent coding practices throughout the engineering organization, streamline the hiring pipeline by focusing on a single tech stack, and concentrate on optimizations like adding the ability to connect multiple databases with active record. As you can see, GitHub was able to get pretty far on a monolithic code base, running a code base that's over 13 years old, pushing the physical limits of what MySQL can handle, serving over 1 billion API calls on a daily basis, and maintaining a highly performant user interface that focuses on getting the job done. Today, GitHub has over 50 million developers on its platform, over 80 million pull requests merged every year, and over 100 million repositories across every continent of the world. GitHub could have easily continued on this growth trajectory without breaking from the monolith. However, some major changes took place that prompted the company to consider a transition towards microservices. In 2018, Microsoft acquired GitHub for $7.5 billion to really double down on its investment in the developer community. And this became a significant inflection point in GitHub's journey. GitHub now has many more resources to accelerate with. And through both organic growth and acquisitions, the GitHub engineering team tripled in size within an 18-month period. With over 2,000 employees, GitHub has also expanded its product footprint into workflow automation and DevOps security. The systems and processes that were developed under the monolith, such as deploy trains and on-call rotations, are no longer sufficient to support this many people working together. With that, I'm going to hand over the presentation to Jovel, who will walk us through some of these friction points and how GitHub plans to overcome these challenges.
Awesome. Thank you, Sha. So as Sha mentioned in her last slide, the series of acquisition brought in multiple products, which means multiple services needed access to the GitHub main code, fondly known as the monolith, or GitHub. It's a URI in joke. Overnight, GitHub needed to support a microservice architecture. GitHub also experienced an explosion of new hovers who all needed to make changes to the monolith. With hundreds of developers needing to deploy, we quickly encountered the perils of deploy limits that was making developer productivity nosedive. GitHub has always invested on deploy automation. For example, some of you may have heard of our friendly sidekick, Qbot. Qbot has many superpowers, but his first and most important task is helping engineers deploy their code to production. With Qbot, you can go through the full deploy cycle featured in this diagram, all in Slack. To start, you can ask Qbot to create and schedule a deploy train for your pull request, or also known as PRs. Once scheduled, other engineers can potentially add their PRs to your train unless you lock it down due to a risky deploy. Once it's your turn to depart the station, you can then ask the train conductor, trigger a set of commands to deploy the changes to 2% of prod servers, so essentially a canary deploy. During the canary deploy, all PR owners are then notified to check for exceptions and any other potential problems. If all is well, the train conductor can then move to the next step of the deploy process, which is phase deploys, up to 20%, 30% to 100% of all prod servers. If all is well again, the PR changes are then merged to the main branch, and the next train can depart. Super elegant, right? However, this abstraction breaks down when you have hundreds of engineers who want to deploy. Even with a well-automated deploy system, it can only be tuned so far. Safe deploy means that you can only do one deploy train at a time in case of a rollback. So in a busy Wednesday morning, you could be waiting for over 5 hours, essentially all day, just to get scheduled to deploy. With these engineering challenges, GitHub engineering spent some time soul-searching to figure out how we can move a 13-year-old code base to meet the needs of our growing family, each with their own code base of varying sizes, age, and needs. Even though we've grown up to a large company, GitHub still aims to maintain that same culture of innovation and wonder. And the following are our lessons learned and steps we've taken to deal with this brave new world. First up, the first lesson is that we desperately needed to extract our authentication and authorization code outside of the monolith. This may sound simple, but it's a foundational change that's made even more difficult due to an established 13-year-old code base. I know, right? Teenagers these days. For the GitHub monolith, not only does everything need auth N and auth Z, but the auth logic is shared and scattered in various pieces throughout the monolith. Changes to auth N and auth Z also needs to be balanced with security concerns. to ensure that we don't make security holes or allow for future security vulnerability. But with an extracted auth N and auth Z, services outside of the GitHub monolith can be built without having to know anything about the main codebase. Second lesson is that investment in tooling to ease development pays dividends. Around the same time that we started extracting the authentication and authorization code from the monolith, GitHub also started investing on the concept of microservices in a box. Using a web form and a YAML, you can request for staging and prod VMs to be spun up in a kube cluster. This may seem obvious to some, but part of the reason why GitHub kept investing in the monolith is because engineers really like working in the Ruby on Rails framework. Besides having business needs driving the need to move to a microservice architecture, we needed to also win the hearts and minds of our developers to convince them that it's better to build outside the monolith than within. And the best way to convince engineers is to make it convenient. Having your own box to deploy code to means you have a dedicated deploy train system. So instead of taking hours to deploy, with your microservice in a box, it takes only minutes to set up and minutes to deploy. Finally, we learned the importance of establishing secure communications between services. While we're in this halfway state of having part monolith, part microservice architecture, cases kept popping up where services either need endpoints that are only accessible to them, or an external services like NPM need access to GitHub internals, but they live in their own data center. Service-to-service auth, essentially with service mesh architecture, has emerged as a key pattern to setting up secure communication that's flexible enough to allow various types of communication, but secure enough that we feel safe making exception and custom access changes for our various family members. So where are we actually at? In terms of service-to-service auth, GitHub still needs to implement something in this area. We're currently surviving with HMAC endpoints and proxy services, so not that good. In the SendGrid use case, I'll actually go over an example of a service-to-service auth setup using a service mesh architecture as an example. With microservice in a box, GitHub has a robust system in place that's a joy to use. I'll also go over in the next use case what happens when you don't have a good provisioning system in place. And finally, in terms of building auth primitives, we do have auth N and auth Z systems external to the monolith, but not all calls have been migrated out of the monolith because we don't have a paved path. And as I mentioned earlier, since it's inconvenient, engineers are unfortunately unconvinced. But first, let's go over our next hero. Our next hero is SendGrid. SendGrid was born in 2009 as an email sending company with a focus on delivering transactional emails and later added marketing emails. SendGrid IPO'd in 2017 and was later acquired by Twilio in 2018. As mentioned earlier, SendGrid is the first company where both Sha and I worked together, but we have it listed here as our second hero's journey to describe the experience of microservices versus monolith in a medium-sized company. A little bit more about the origin story of SendGrid. In the beginning, SendGrid had three very technical founders who each built a piece of the mail pipeline. First up is Jose, who built the sign-up, login, and management dashboard. Then Isaac built the mail API and mail relay systems, while Tim built the mail filter and the mail transfer agent. So from the start, SendGrid had microservices in its DNA. In fact, when I joined in 2014, the full architecture had expanded to more services, but here I mainly wanted to highlight how the API was separated out of the UI and that all access went through this abstraction of the data access layer that sat on top of functionally sharded databases. So you might be thinking, sounds like SendGrid had it good. What's the problem? While the mail pipeline may look like an ideal microservice structure with many parts broken into its own services, SendGrid, who owned their own data center like GitHub, did not have a robust microservice in a box solution like GitHub. And so instead of having separate servers to host these separate services, let's just say there's some server bloat happening. In the case of the filter servers, there were actually 5 services sharing the same server. One of them is a process-heavy step in the mail pipeline called the mail transfer agent. How did this happen? It was more convenient to keep adding new services to existing servers, and it was also convenient for ops to just add more physical hardware to the same cluster of servers. Also, while it's awesome to have an API gateway that handles all APIs, SendGrid encountered developer velocity issues when developers all had to define their endpoints in one service. Similar to the deploy train issue in GitHub, granted at a smaller scale. This accidental monolithic structure can also be found in SendGrid's data service layer. While it added an abstraction to ease access over the sharded data, anyone can add new functionality to the data layer, which means data owners don't know who's accessing their data, a compliance risk. And any bad deploys to that data layer can take down other services, so you have splash damage. On top of that, SendGrid, like many companies who own their own data center, followed a pattern of having a hard outer shell but a squishy middle, which means that all microservices within the data center can talk to each other unhindered. This is fine when you're starting up, but this can also lead to compliance issues, especially when a company wants to IPO. Also, usually load balancing only happens at the external request layer, so internal services could sometimes DDoS each other, especially when some services scale at different rates than other services. And as icing on top of this problem cake, because of our seasonal traffic, SendGrid made a business decision to move all services to AWS circa 2017. So where do we go from here? How can a mid-sized company continue to innovate at a speed to ensure year-over-year growth with such foundational issues and shifts? Well, first up, we needed to handle issues of bloat. The SendGrid architecture team, which oversees all new projects, made a pronouncement that all services should be built with data contracts and data isolation in mind. This means that all new services must have an API, the contract, and only that service can access its data isolation. So we then incrementally applied these principles to the shared data service layer to slowly chip away functionality and data access from it. However, like in GitHub, the only way to enforce these engineering requirements is to provide a convenient way to accomplish these tasks. But with the partially working provisioning system, progress was slow. To relieve the back pressure internally, SendGrid heavily invested in setting up a Kafka system throughout its network. SendGrid has probably the most redundant Kafka system setup I've ever encountered, since a core business objective for SendGrid is to not lose any mail. A messaging system with all the defensive programming of retries, caching, circuit breakers, and with SendGrid especially, 3 levels of storage per message as backup, are a must for a reliable communication within a distributed network. However, a messaging architecture is just part of a solution. The gold standard for establishing secure communication to meet compliance and security needs that's also scalable and maintainable is a service mesh architecture using Envoy proxy with Kubernetes. With a control plane, either do it yourself or using pre-built ones like Istio or Console, you can take care of microservice needs of rate limiting, batching, caching, and routing. And with a data plane setup using Envoy as a sidecar, you can fulfill microservices best practices of retries, tracing, circuit breaking, while restricting who can access a service. But unfortunately, this gold standard setup requires that you have majority of your services already in queue. For established companies, that may be a lot of baggage to migrate, which is the case with SendGrid. To get around this, we decided to apply a compromise and set up a gateway of gateways instead. Migrating services from a data center to a cloud provider cannot happen overnight. So the approach that SendGrid took is a hybrid system that allowed us to build in both locations until we can migrate everything over to AWS. I can probably spend an hour on the design decision encapsulated by this diagram alone, but I just wanted to mention a couple of things that this architecture allowed SendGrid to do. First up, we used Envoy as the front load balancer since it's extensible enough to attach an auth and rate limiting system that we then synced with the matching rate limiter and auth system in the SendGrid data center. With these 2 sync points, to the customer, the experience of using services that only live in the SendGrid DC versus services in AWS is seamless. Mainly, your rate limit stays consistent between the 2 locations. Next, From the SendGrid developer perspective, as long as you use an AWS API gateway and the provided validator that can talk to the custom-built token service, developers can then build their own APIs and services in whichever tech stack they want in AWS, which in the case of marketing campaigns is an extensive set of AWS Lambdas. With the ability to provision their own services, SendGrid devs are now able to easily follow the pronouncement of data contracts and data isolation. Also, since they can set up their own AWS API gateway, they can make and deploy API changes independent from other SendGrid development teams, reducing splash damage for everyone.
All right, on to our last hero. Last but not least, we introduced our third and newest hero of the story, Catalyst.io. Catalyst was founded in 2017 to help companies bring customer success to the center. The company is almost 4 years old, and its product has been around for a little less than 2 years. With $45 million in total funding, Catalyst is viewed by our investors and customers as the disruptor in the customer success space. The expectations are high for us to triple our revenue and double our employee base year over year for the next couple of years. And there's a ton of momentum and energy as everyone gears up for the rocket to take off. In order for us to bring customer success to the center, we have to integrate with many sources of data and help our customers build a centralized view into their customer base. For example, we currently bring account data in from Salesforce, Zendesk, Jira, and usage data from Segment and Mixpanel, as well as a variety of data warehouse solutions like Snowflake, Redshift, and BigQuery. Every customer's data and use cases are quite unique, and this leads to the next stage of our hero's journey. At this stage of the company, top-line revenue growth is the #1 success metric, and being able to add new customers is our #1 priority. As you can imagine, at this growth rate, with all this data coming in through a shared pipeline and funneling into the shared database, we are starting to see signs of stress in our system as we continue to scale. A couple of months into my new role as head of engineering at Catalyst, I started to notice a pattern of fear and uncertainty coming from my team. Without great instrumentation in place as an early stage startup, a lot of developers have been picking up anecdotal signals of potential problems. It may be a spike in load here, or a slowness in performance there, or maybe getting paged several days in a row for a production incident. Every major feature release and every large customer onboarded felt like a huge gamble to us, as we held our breath to see if this will be the next one to tip us over. This is a really bad spot to be in as an engineering team, because it really wears on the team's confidence and can cause irreparable damages to the business when there's an extended outage. So we knew we needed to act, and we needed to act fast in order to get ourselves out of this situation. As a fast-growing startup, there are lots of constraints to work around. There's a lot of momentum on the sales side, which is a good thing, and we're seeing fast revenue growth and larger customers coming onto our platform. However, because of these added load, we're also starting to see strains on our production system. We know we needed to act fast, so we have limited time to complete a full diagnosis and redesign the entire underlying architecture. And we have a fairly small engineering team that also needs to keep feature development going while continuing to build up our customers' trust. So what are some options we evaluated at Catalyst? And how do we apply the learnings from the previous two protagonists to help our last hero find her own path forward? We focused on 3 things given the limited time frame. First, we did a high-level architecture assessment to identify some quick but high-impacting fixes to help us remove some immediate bottlenecks in our system. We then applied the concept of horizontal scaling to stamp out more duplicates of the cluster we already have in place today. And finally, we started taking the first steps towards building a foundation for our future selves as we continue on this growth journey. Here's an example of a quick and high-impact fix that was implemented within 24 hours. Sidekick is a critical component of our application. Sidekick relies on Redis instance to store our jobs queue. Redis is single-threaded, so reading and writing large objects can block all other readers and writers for some time. a bulk customer update can easily cause Sidekick to stop responding and impact our ability to continue processing requests from other customers. The reason that these jobs are so big was because we stored the entire object inside of Redis. The fix was simply to push a record ID into the queue instead and have the actual large objects be stored in Google Cloud Storage, which is the equivalent of S3 in GCP. Now, a job is only the description of the work to do versus the actual large object that contains everything. Our second solution was to introduce the concept of horizontal scaling. Without having the time to look too closely under the hood, we just built a second cluster that duplicated everything we have today. This new cluster is completely separated from the first cluster, and we can either migrate existing customers or start adding new customers onto the second cluster. Because it is an exact copy of the first cluster, we know that it can handle at least the same amount of workload that we have in our system today. In order to make this multi-cluster system work, we also needed to build a routing service that knows how to identify and route customers to their right assigned clusters. Having more clusters also allows us to migrate and isolate problematic customers without it impacting everyone else. And this is not just a short-term solution. This is an approach taken directly out of my experience at SendGrid, where we had carved out separate swim lanes for different types of customers. This also allows super large customers to eventually have their own cluster that can be provisioned and customized based on their specific usage needs. Many of the lessons learned from GitHub also directly translated to our decision to start building a foundation for scale early on at Catalyst. We created 5 teams and introduced the concept of team ownership. We took our entire feature set and divided them amongst these 5 teams. We then moved authentication, authorization, and the routing service outside of the monolith as our first set of core services. And finally, we just started the process of rebuilding the various data ingesters, each as their own microservice. Creating this foundation of scale will give us additional options and flexibility, and the confidence we need to tackle whatever our future holds. Now I'm going to invite Jovel back to talk about her key takeaways through this microservices journey.
Thank you, Sha. So my top 3 takeaways are, first up, know your why and make sure everyone knows this why. When moving between monoliths and microservices, a strong understanding of why you're keeping something or changing something can help safeguard against things like bloated architectures. And especially when you need to make a change, it will help keep focus on the work, since foundational changes are like the most painful change that people can work on, and most people will try to get out of it. Next up, what's convenient is what gets used. Whatever tool, best practice, or general direction you want your team to go down on will be determined by what's readily available and what's the most accessible. To course correct, you need to establish a paved path towards that new direction. Finally, start with auth-N and auth-C. Pulling these 2 services into their own centralized service location with control over their own data will help enable the development of new systems inside and outside your preferred service architecture, and would help with any type of integration request.
All right, and my key takeaways are: make intentional and pragmatic decisions. Keep in mind that architecture changes can have more broad impacting organizational and operational consequences, such as on-call, team structure, and deployment workflows. There is no one-size-fits-all solution. Some things are easier at an earlier stage, and some things are easier at a later stage. It all depends on the different sets of resources and constraints that you're working with. And finally, creating a foundation of scale and introducing some best practices early on is never a bad idea, because it will give you more flexibility and better options down the road when you encounter unforeseen roadblocks and challenges on your journey. Thank you so much for attending our talk today, as we took you through the story of 3 heroes' journey towards self-discovery and their transition towards microservices. We would like to thank the organizers of CraftCon for giving us this opportunity, and we hope you found this content helpful. And with that, we would love to open up the floor for any of your questions.
Hey, thank you very much. Big applause to you. And very nice presentation. Thank you very much. And very nice work indeed. So really liked it. I already have seen that there are questions in the Q&A where we you provided some of the answers for it. Can you elaborate on the answers? So how do you handle database schema changes in combination with canary deploys? Are you always backwards compatible? You mentioned in your answer you probably don't worry about that much. But what if you would worry, or you know, how would you approach this problem?
So in terms of backwards compatibility, that's fairly difficult to maintain if you have a large sets of data. And I guess in a way, it depends on the change being made. I might need a little bit more context on like how this question is being asked. If you need to like migrate the the content from a new set of table to a different set of table, then we do use like other toolings, like I believe we use Vitess, so that data is written in both sides until all code has been transitioned over, and then you switch over to the new set of data. But yes, I guess in that sense, we're backwards compatible. But as much as possible, people try to write code where you can just keep moving forward, and it's like incremental. It's a little difficult I mean, it's a lot of little steps to do that, but it's like the most safe for maintaining data. Of like, you just modify the code so that it can handle two kinds of data, make the change within like the column that you are making changes to, and then move forward again and remove the code that is detecting the old data.
Yeah, and then also, you know, at Catalyst, at the current stage, we don't worry too much about backwards compatibility. Usually we just have a pre-scheduled maintenance window during a kind of a low period of usage, and we let our customers know ahead of time. And that's when we make all of our data migrations. You know, additionally at GitHub, I remember we were going through a bigger data schema change. And so that was a very intentional planned change where we kind of separated things into more functional groups, had a YAML file, and then during our CI/CD process, we actually had a linter and a query watcher, you know, before things ever made it out into production, so we can alert when boundary conditions are not enforced and things like that. So.
Thank you very much for the answers. I have a question myself. You decided to use Envoy technology, right, for doing this load balancing. Were you considering any other? So was there any other that you consider, or did you just went straight for the Envoy?
So this was a few years ago, so I don't completely remember all the details. I mean, I think essentially we're considering different kind of load balancer schemas. Like you could go down like whatever gateways that AWS provided. Do we want to just use the AWS API gateway? At the very top, like I was talking about how we had like gateways of gateways. The individual microservices had their own AWS API gateway, and then those talk to like an Envoy service. We did not go down the AWS API gateway because it wasn't flexible enough with what we needed. And something going down the route of like something like HA proxy, while that's a fairly well-known technology, it doesn't have as much like bells, the connections you need to like set the rate limiters and auth customization that we wanted to do with Envoy, so that it can act as overseer over like essentially two different kinds of cloud data centers, cloud providers, SendGrid's own data center over AWS, like the cloud setup there, because actually HA proxy was used on the SendGrid data center.
Okay. Thank you very much for the answer. So at the moment, I don't see any more questions, but I would like to show you something. This is too much. And I hope you recognize yourself, so it's a little bit of a fun picture of you. You will receive this. This will be shipped to you. Thank you very much for your presentation. I hope you will enjoy some coffee or tea out of it. So at the end of the day, I would like the audience to give one more applause to Sha and Jovel, and then thank you very much. And I wish that you can stay with us for the conference, chat in the different streams, and get a little bit socialized. And I wish soon we will also have the opportunity to invite you here to Budapest, where we host the conference, so that you can visit the city as well. Thank you once again, and thank you for giving this wonderful talk. Cheers.
Thank you.
Thank you so much.